In this video, I'm going to talk about force and the many types of forces that influence the motion of objects in our world. So let's start with a basic definition of force. Force, as you may remember from earlier science classes, is a push or a pull on one object that is caused by the interaction of another object. We have two broad categories of forces. There are contact forces, which the two objects have to be in physical connection in order for them to happen. These are things like friction and air resistance. And then there are forces that we call action at a distance, where physical connection is not needed. Gravitational forces, electrical and magnetic forces can all exert force on an object without being in physical contact. Force is measured in a unit called newtons, and I guess you can guess who that is named after. 1 Newton represents the amount of force needed to give a 1 kilogram mass an acceleration of 1 meter per second. Now, force is a vector, so you must include both magnitude and direction when you are talking about force. As an example, we have a physics textbook over here on a table, and so gravity is pulling downward with a force of 20 newtons, and then the force of the table, or the normal force, is pushing upward with a force of 20 newtons, so that the table, we can tell that the textbook on the table is at rest. No acceleration is happening. There are quite a few types of forces, and I want to go through each of these and give you the abbreviation that we'll be seeing in the worksheets. So the first one is applied force, and its abbreviation is a capital F and then the little letters APP as a subscript. So applied force, as you can see from the name, is the force that is applied to an object by a person or another object. And so when you have a person, pushing on a refrigerator, as you often have in these kinds of problems that we'll be seeing, or, pulling on a wagon or something, those are applied forces. They are force applied to an object. The force of gravity, which is using GRAV as our subscript, which we also typically just call weight. Gravity is the attractive force that a massively large object exerts towards another object. Now, in actuality, anything with mass is giving off a gravitational force, but we really don't notice it in real life unless we're talking about something that's very large, like a planet or the sun. All objects on Earth being that massively large object, all objects on Earth experience the force of gravity as it is directed downward towards the center of the Earth. We can calculate gravity by multiplying the mass of something in kilograms by the unit of gravity, which is 9.8 newtons per kilogram. Often that's just abbreviated to 10 newtons per kilogram since it's so close. The normal force is considered the support force exerted by an object in contact with something that is a stable object. So that textbook on the table from the previous slide, the table was exerting a normal force, a support force on that. Most of our support forces we experience in life are horizontal forces, such as a table, but it can be a vertical force as well. If you lean up against a wall, you're experiencing a vertical normal force. Then we get to friction force, which is the force exerted by a surface on another object. And this is due to attraction between the molecules, so intermolecular forces are involved in friction. We have two types of friction, static friction and sliding friction. Static friction refers to the friction that an object just resting on something, the friction that's felt at that point, and you have to overcome that static friction to get motion going. And then you have sliding friction, which is the friction that's occurring as that object is sliding across the surface and the forces that are interacting down on the molecular level at that point. In general, friction usually opposes the motion of an object. It is in the direction of the force is opposite to how the object is moving. The next type of force is air resistance, and this is a special type of frictional force. This is the force that the molecules in the air are actually exerting on objects as they move through the air. In actuality, air resistance, even though it's happening all the time because we're surrounded by air, we ignore air resistance because most of the time it is only providing a small amount of force. The times where air resistance comes into play is when objects are falling from a great distance, it's something is skydiving, or something's going very, very fast. And so then we will consider air resistance, but most of the time we don't include it when we're thinking about the forces on an object. Tension force refers to the force transmitted through this should be a string, I see I have a typo, a string, a rope, or a cable or wire when it's being pulled tight by forces acting on either end. And the tension force pulls equally on these two objects. And then finally, we have spring force, which is the force exerted by a compressed or stretched spring on that object that's attached to that spring. The object that is involved in changing the string's length, either by compressing or stretching it, is acted upon by the force that is restoring the spring to its equilibrium point, back to, sort of its natural relaxed state. And so that's how we figure out which direction and the amount of newtons in that force. Before I finish, I just want to talk a little bit about mass versus weight, since this is something that gets confusing since we sort of use it interchangeably working within this single gravitational system here on Earth. But mass, technically, is the amount of matter in an object, and it is dependent on the number of atoms and will not be affected by changing the location of the object or how much gravity is pulling on that object. Mass is the identity, really, of the object. It doesn't change. Whereas weight is dependent on the force of gravity available to act on an object. And weight is affected by the size of the massive object that's creating that gravitational force, and then how far the distance is from the massive object itself. So the forces of gravity diminish over distance. To give an example of this, let's consider a 1 kilogram mass and how its weight differs between Earth and Mars. So on Earth, this 1 kilogram mass is influenced by the force of gravity that is 9.8 meters per second squared, which results in a weight of 9.8 newtons. Where on Mars, where it is a much less massive planet, the gravitational force is only 3.72 meters per second squared, resulting in a weight of 3.72 meters. So mass and weight, make sure you're clear on the difference. Even though we use them interchangeably on Earth, in reality, they are two very different things. So check your understanding. After watching this video, can you provide the definition of a force? Can you give examples of the contact forces we have acting upon objects in our universe and the action at a distance forces? Can you identify the unit of force and explain how it is calculated? Do you know the definitions of these different types of forces and how we abbreviate them in formulas? And finally, can you explain the difference between mass and weight? Of course, if you're still confused, the first step would be to go back and listen to those parts of the videos again to see if you can get these concepts clear in your mind.